Well, there we go. Apparently, there's a recording in progress. Hooray. All right, so are we still giving a few minutes for people to show up, or should I just go for it?
I would say just go for it. People have been filtering in. Yes, yeah. So just go for it.
Okie doke, sounds good. So, this is creating animated LED displays, which can be used for 8,000 different things, whether it's Amtgard or not. Um, there's a lot of Halloween displays or those musical Christmas displays that use basically the same thing. And it's surprisingly cheap and easy to do. Now, I'll show you the brains of the outfit, which is not me. It is this little guy. This is called an ESP8266 microcontroller. It can do anything. We flash a firmware on it that tells it, hey, you're going to control LEDs now, and you're also going to be a web server. But before we get to that, I should probably cover how electricity is bad. Because a lot of people think voltage is the bad thing, but it's really not. It's amperage. When you're dealing with a lot of 5-volt LEDs, there's a lot of amperage. My power supply that I use at my workbench is 40 amps. So you can see why I'm really careful about it. And I really want people to be aware of how dangerous it is. Because I don't want you to die, generally speaking. So electricity is bad. It doesn't take much to kill you. So these are a few project ideas that I kind of came up with. Just for Amtgard purposes, if you get some of those aquarium jewels and stick an LED display under it, all those lights are going to shine right through. And I'll show you an LED matrix that does a spectacular job of doing it. If you saw the video I posted on the event page, that's the one. You can do camp lighting. These LED types actually come in like Christmas light strings that you can hang up. You can get them to go up around your house permanently and they're waterproof. There's a lot to do. I've also heard of people using a clear polycarbonate tubing in an Amtgard sword and then running LEDs up the center. And with enough power, you can get them to shine all the way through translucent foam and have an actual lightsaber when you're out on the field. Light up shields, I've never actually seen it done because we have that 1-inch foam requirement over any kind of core for shields. So it'd be kind of tricky. Night quests, I've seen battery powered lamps, and one of the really cool things about this system is that you can network all of your lights together, even if you have them on different controllers. So if you change one, it changes all of them. Or if it does a pattern, it does the pattern throughout all of them. Tavern lighting, court effects, anything. Um, Then back to real life examples. I personally wired up a set of these into my under cabinet lighting, and those work fantastic. There's a relay hidden behind the light switch on the wall that controls the other under cabinet lighting, which is dumb lighting. And as soon as that switch gets flipped, it tells the LEDs to turn on too. Automated staircase lighting is another really cool one. Somebody rigged up a motion sensor to it. As soon as the motion sensor tripped, the lights actually kind of walked up the staircase. Like they didn't all turn up at once, it was gradual. It was really cool to watch. but I don't own that video, so I'm not going to show it. Underbed lighting, that's great because my room is in the basement and is pitch dark when my wife has already gone to sleep. So I have underbed lighting that I can turn on with my phone. But anything you want to light up, you can. The system's totally networked. You can address individual LEDs, and it's dirt cheap, which is one thing I really like about it, because if you price out the controllers buying them separately, you end up paying, $50 to $100 just to control your lights. It gets really ridiculous. Whereas this little controller that I have is about $3. And that's ordering it from Amazon. If you ship it from AliExpress, the cost drops down to, I've seen as low as 75 cents a piece. It's insane, which I'm going to say a lot because how much money I've saved doing this myself versus buying something it's pretty wild to me. So one of the first things I want to do is kind of show you a little bit about the actual lighting system, and then we'll dive into planning an LED project and then soldering and containing all sorts of stuff. So first one, I'm going to switch to my overhead camera, which is pointing at my desktop currently. And with any luck, I will be able to turn these LEDs on. I've been plugging, unplugging, soldering, unsoldering for a week now, so bear with me. Okay. My apologies, this one's being a little dumb. Okay, I'll switch it over to another one. This is kind of the way it goes because I have 5 or 6 of these sitting right here. So just to ask, can everybody hear and see everything okay?
Yeah, you were quiet for a minute. I was be like, okay.
That
Yeah.
I was bending over to pick stuff up off the floor.
Okay, yeah, that's good. I see everything, but sounds good. Perfect.
Oh, and just to show you, this is the power supply that I have as I throw my controller on the floor. This one is, I think, $30 or so. And not too bad, but not something you want to have out in the middle of an Amtgard field. For that, you need an enclosure, you need fans, you need stuff to keep it cool. Okay, let's try this again. I'm gonna bring out the LED matrix, which that was kind of gonna be the surprise for the end, but it's the one that I know works. Okay, and then I was going to talk about enclosures once I got to this one, but this is really all it is. We have, sorry, my camera is mirrored. This right here is a 3.3 volt voltage regulator, also called a buck converter. That'll take in the 5 volt, drop it down to 3.3 volts, which is then feeding this guy right here. Now, this is not an ESP8266 that I was talking about. This is an ESP32. This is that one's big brother. It is a lot more powerful, has a lot more processing power, so it works better for things like this matrix right here. But if you're just doing strips, then the 8266 worked great too. I'm kind of picky about speed on it, and when you're running over 500 LEDs, you need a little more speed, or it looks awkward. Okay. Just hooking this guy up to power. Can you tell that I haven't taught in a while? Ha. Oh, and this case that the controller board is in, this is just 3D printed. Took me about 2 hours to print. I do have a handout that details all of the steps that I took to arrive at this particular design and everything, and I will be publishing that as soon as it's actually done. Because if any of you have any questions, feel free to ask them, and I will incorporate the answers into the document.
Yeah, if you could, could you send that to me when you're done, and I'll put that on the website too?
I absolutely can.
Thank you.
Okay, here we go. Now, I should actually be using much heavier wire gauge for this, and were I installing it permanently anywhere, I would, because this will be carrying a lot of amperage, and more amperage you're carrying on a little wire, the higher likelihood it will melt, cause a fire, start arcing, burn your house down, all that fun stuff. But for this particular purpose, if it's only on a few minutes, then it's not going to cause any huge disasters. But just remember, electricity is bad. Okay. Oh, while I'm doing this, I will go over some of the other wonderful integrations you can do with this. Because there are several smart home systems, such as, of course, Google Home and Alexa and whatever, I think they call it Apple Home or something like that. I don't know. I don't use Apple products generally because they are not huge fans of the DIY community as a rule.
Yes, please keep your use of the A word down a little bit.
Oh, yes. I forgot you have
I have
that
all, yeah, I
system.
have everything in my office, not everything, but a lot of things in my office are controlled by the A word.
Oh, I could have so much fun with this.
Oh, trust me, I have friends that set an alarm every time to leave the room if I'm doing a video chat to go to the bathroom or something. It's good times. Good times.
Of course they do. Yeah, I used to like when we were playing D&D during the lockdowns and stuff on Roll20 and all that. I used to have my little Google person right next to the speakers until somebody figured out that you could tell it to play music. And this was at 11 p.m. while my mother was going through chemotherapy and radiation. I was not a happy person.
Oh my gosh.
Yeah.
Yeah, I can imagine.
Okay, we're all hooked up. Sorry about that. Boom. Bright lights. Okay, gonna dim that quite a lot. Okay, now is that too blinding?
Nope, that's good.
Okay, cool. That is about 5%. And while this power supply can max out on these LEDs, it can't fry them unless I put like 12 volts through it, which would be dumb. There we go. Much easier. So, um, come on, really? Stop doing that. Okay. So, this right here on my phone, I apologize, it is backwards. It's the only way I could get the camera to actually show things and not just show my crotch. But on this app, which this is not a cloud app at all. This is actually it's a web server that's being hosted on the controller. It's completely secure. It is completely yours. You don't have to worry about somebody else gaining access to it unless you do something silly like, oh, I don't know, making it an open network because it will actually broadcast the Wi-Fi for you. So if I want to change the color, I do stuff like that. And now it's purple, now it's blue. And one of the absolute best things about this, you can show effects, you can show animations, turn it into a clock, anything like that. Now these are particular animations to an LED matrix, but even the strips have their own stuff, like a candle, a rainbow that just goes up and down the strip. There we go. So if you imagine these rows laid out in a long strip, that would be what it looks like. Okay, I'm going to turn this off so I don't give anybody a seizure. And like I said, all controlled by the phone. And you could run it by battery. I've never done it before, particularly with 5-volt lights, because once you get up into the higher amperages, it's really hard to find a battery that will actually do it. Okay, I am going to turn my power supply off and sit this guy aside so we can kind of go over what we're looking at. Okay, back to our web view. For an LED project and any project really, one of the first things you want is to ask yourself what you need it to do. So if you're doing under cabinet lighting, you just need a short length of channel and something to hold it up. You could even do it without the channel, but you'll need to figure out a way to diffuse it. What kind of LEDs do you need? If it's plugged into a wall, you're generally okay with the 5-volt stuff. But if you want it, say, outdoors or very long strings, like if you're doing house lighting, you would generally want 12 volt. 12 volt carries voltage a lot further. 5 volt, you need to do voltage injections every 20 or so feet. Otherwise, you start to lose power and control to the end. If you turn them all to white, the opposite end from the power supply is going to be red because that's the lowest power LED that's in here. Okay, while I'm talking about LEDs, I'm going to switch to my microscope, which is currently completely black. This is a burned out LED that I cut off from a strip. But if you look in here, you can actually sort of see the different zones. So there's one LED here, one LED here, and one here. And then they just combine. But you're dealing with power for each of those LEDs. Basic component. All right, so next for outlining the project, how long do you need it to be? Because that will tell you how many LEDs you're actually going to need. Are you going to need 500 or are you going to need like 30 of them? Most LED strips are actually not as long as you would think, or rather not as dense. So switching back to my overhead. This is one of the channels, very similar to under cabinet lighting. This is a 100 density LED strip. You can get it in 5-meter lengths for about 25 bucks. Okay, but the problem with getting the 100 density versus something like the 144 is if you look directly at it, you're going to be able to see the LEDs. They'll show up as basically hot spots if you have it at a really bright level. So you can go with the 144 segments, which I don't believe I have any on me right now. No, I don't. I think those all got used up. Oh well. But they're extremely dense. They take a ton of power, and I don't recommend them at all. But the other question you need to ask yourself is, do you need white? The 3 RGB LEDs can make white, but it's not a true white. There are dedicated white LED strips. They have the RGB and they have a dedicated white channel. So if you're doing under cabinet lighting or a white lightsaber like Ahsoka, I would go with those. But other than that, you can do any of it with any of these things. You're not restricted into one type of strip, one type of controller. There's just limitations. Okay. Next, I want to talk about power. So kind of what I was talking about. Switching back to the webcam. There we go. Get a little more zoomed in. Okay. So each of these, sorry, I'm looking at this mirrored. These ESP modules, most of them are going to have a USB port on them. That's really only for firmware, or if you're separately powering it from, say, like a cell phone charger or something like that. Those work great because they'll actually regulate it down to the 3.3 volts, and then you don't need this. But you'd still need to power your LED strips separately. So this is one of the circuit boards that I'm going to link to in the document. It is by a company out of New York called Adafruit Industries. They have done so much for the do-it-yourself community, but they are quite expensive. Like the same LED strips that I buy from Amazon for $30 are like $60 from them. But if you take a look at the board, right on the bottom, you have all of these little lines. I'm going to switch it over to the microscope so it's easier. So you can see each of these holes is connected in a line. The way I like to set mine up is that your input line, let me find it. There we are. This is the what I call the input rail. That brings in the 5 volt, and then that 5 volt transfers all the way to the other end where I have the plug for the LED strip. This side is the negative, the red is the positive. And the reason I do that is so that I'm not powering the LED off of the ESP itself. It can do a few LEDs, but you will burn out your controller very fast if you try to run through any more than about 10 LEDs. They don't like it. Okay, back to the web page. Okay, so we've answered a few questions. How are you going to power it? I have a bunch of links in the document showing different power supplies, but really you need a dedicated 5 volt supply for the LEDs and a way to step down for the ESP module. 12 volts going to blow out the ESP module possibly in a spectacular way because it has capacitors on there that may actually explode. Now, wiring. I have the link to this in the document, but I'm also going to show it. This is the WLED power calculator. This will tell you every single little thing you need to power your project. You select the type of LED you have. In the case of my matrix, I have the WS2812B, which is just RGB. It takes 5 volts and it meets a certain standard for how many amps each LED takes. Here, I'm going to be controlling RGB, and there is no dedicated white channel, so this is the maximum power it could take. For physical LEDs, there are 512 of them in that matrix. You can do things like changing the brightness to 50%. You can limit it in the software so that it doesn't actually blow out your power supply or blow out your ESP module. Voltage drop is really how far it needs to go or how far it can go before it starts losing voltage, and then you have less control over your LEDs, as well as them just in general being dimmer. Now, I'm going to zoom in on this. Okay. So the LED power consumption for this matrix is 21 amps. A lot of things aren't going to be able to power that, and I'm supposed to be running it on 12 gauge wiring. I don't, because it's not on very long. So this just kind of gives you an idea of where you need to start. Okay. For my next trick, I'm going to show you how to solder one of these because it is really easy. Not to mention, it's already 3:30. I should have requested more time. That's my bad. Okay. So the bog standard for soldering is just a run-of-the-mill $20 soldering iron from Menards, Home Depot, Lowe's. The problem you run into with those is that you cannot control the temperature of them at all. You can end up burning circuit boards, melting LEDs really easily. Like you saw the example I showed where it was kind of melty on one side. That was because I was using a cheap soldering iron. Now, this guy right here, this is called a pencil. Let me get the display to flip. There we go. It is a smart soldering iron. Every bit of temperature control is on here, and I can change it any way I want. It's great, but it's also sort of expensive. The tips for it, as well as the unit itself, cost me about $100, as well as this power supply, because this puts out a full 65 watts into a USB port. That's right. This thing's USB powered. I can use a barrel jack, anything like that. It is great. It's not required. You can do this with your standard soldering iron with no control or anything like that. You just got to be really careful not to melt the components that you're trying to solder. All right. Switching back to actually soldering. There are two schools of thought on which solder to use for electronics. There's old school, which is lead solder. It's not very good for you. It can produce some smoke and, all the problems that lead brings. Then there's silver solder, which doesn't put off harmful fumes, but it is a lot harder to use, specifically because it just doesn't like to flow on electronics nearly as well. When you're soldering, what you want to do is heat up the component first. You don't want to melt solder onto the iron and then stick it to the component because it's not going to work. You're going to end up cooking all of the flux out of the solder and it's not going to flow. So I've heated up the metal bit, then I'm just going to poke it. Need more? Poke it a little bit more. And it's soldered. And that is the 3.3 volt connection for this board. That's where you'll connect any power supply or converter to if you aren't running it directly from the pins, which again, I don't particularly recommend, but it is doable. It's not going to hurt too much, but it's not going to be great for it. But for this particular one, I am going to run it directly off of the board because I can, and then I'm going to connect it with USB. So I have 3 wires here. Here's my neutral wire, It's also called negative, but electricians, electronics technicians, everything, they call it the neutral. Typically white, sometimes black. It doesn't matter what color wire you use when you're doing this, as long as you are consistent and it tells you what it is. Red, this one pulled some green off from the next wire, but it is red. This is always going to be your positive. That is the standard across industries. And in this case, my data wire, which is the third wire, is going to be green. So, taking a look at this, I have labeled on this board, I have G, which is going to be my ground or my neutral, and right next to it is D4. Those are the pins I'm going to use because D4 is the default pin that WLED likes to use. So I'm going to grab this guy and put it into frame and not be bad at my teaching job. Oh, and would you look at that? The 5-volt is right next to it too. That's super handy. So, because I'm very much a clumsy person, I'm going to use tweezers so that I don't burn my hand. Getting solder off of your skin is really not a pleasant task. I recommend tweezers. Get the metal ones, not the plastic ones. You'll thank me later. All right, so basic soldering. As you can see by the end of this, I have done what's called tinning to this wire. You strip off a little portion of it, and then you just gob on a little bit of solder with your iron. What this does is it will use kind of like a capillary action, like a plant does, and it will run solder into the wire and make it a lot stiffer and easier to work with. So rotate that. I'm going to grab my soldering iron. And then I'm going to kind of hold it down. I have something called a helping hand that I'm going to use in just a moment, but I want to show you how to do it without that. So you hold it down with the wire, and again, just kind of poke it, and then pull it away. And that connection is soldered. It's not a great connection by any stretch of the imagination, but it will function, it will connect. I'll just have to make sure I keep the other wires separate. Okay, now next, I'm going to pull up my helping hand. Now, a helping hand is really just it's a work holding tool. You can use a circuit board vise. You could 3D print a circuit board vise. I've seen several different ways to do it. And basically, this just grabs onto the work, holds it steady for you. Nice and handy. This one I got on Amazon for $23. And it has served me very well throughout all of the housing projects that I've been doing lately. All right, so that is clamped on into my circuit board. And as soon as I get this connection soldered, I'll show you how it's kind of set up. Next, I'm going to grab my 5-volt. Actually, no, I'm going to do the neutral next. Now, the other thing I also wanted to bring up is vision while you're doing this. Now, I soldered a lot of these little connections with the help of a little magnifying glass that had a light on it, and it worked okay until I started getting migraines and having really messed up vision. that part wasn't so fun, especially given that I was soldering for like 8 hours at a time. So I saved up my pennies and got this microscope for about $150. It has paid for itself in op, optician bills already. Now, not everybody has that. Not everybody has my vision problems, but I recommend it for anybody who is working with very small things. If you do very fine embroidery, I'd recommend it for that. Really anything, just save your eyes. There we go. Okay, sorry about moving it out of frame there. It just did not want to hold. Now, one thing I would like to call your attention to is these little hairy pieces sticking off the wire over here. Those are not good, especially right next to the 5-volt one, because that is going to cause the power to arc and it will probably fry the board. So I'm going to just kind of bend those out of the way for now. Ordinarily, I would desolder this entire piece and take it off, but this is supposed to be the dirt simple, anyone can do it method. So I just pulled them out of the way. And then I'm going to grab the 5-volt. I'm going to grab the 5-volt. And there we go. Now, that's an entire connection for these LEDs. That's done. So, oh, okay. And the other fun part is I just remembered why that LED strip didn't work. I didn't follow my own rule, and I soldered the wires on to the wrong color. So, for this LED strip, the red one is actually the ground. I think it was about 3 a.m. when I did that one. So I'm going to go with that as my excuse and not, I'm just silly sometimes. All right. Where's my pin? Now, using this connector, I am cheating a little bit because not everyone's going to have these connectors, except they include them with the package of your LEDs. So once you have a controller, all you have to do is literally just solder on or somehow connect, because there are ways to use pins on these boards and then just plug it in. But come on, I'm running out of space on my little table. So this was the helping hands that I was telling you about earlier. $23 on Amazon. It has 4 arms, so I can actually work with some, pretty heavy circuit boards. Not that I generally do, but it's nice to have the option. Okay. So next, and honestly, feel free to contact me on Facebook if you have any questions. I'm not a professional teacher. Um, and I'd be happy to personally walk anybody through this. That's not a problem for me at all. Okay, so the next part we're gonna do, we're gonna flash the firmware on it, which sounds really complicated, but it is absolutely not. So uh, I have my board here. I'm connecting it to my computer with the USB cable. Okay, so that's connected. And we'll see if this works. With these particular ESP8266s, they can be a little finicky with Windows and the drivers, but they made a program where if you have a problem installing WLED, all you have to do is install the driver and you're good to go. Most of the time it works. Um, let me just... Okay, so sorry, I'm trying to get it to show you this part, but there's a pop-up window that comes up that I wanted to show you, but it's refusing. So bear with me, folks. Oh, goodness. Okay, so now it's capturing my monitor. So we click install, and this little window pops up. Do you want to connect to a serial port? If you're creating a bunch of LED displays, only plug one in at a time. Otherwise, you're gonna get confused on which one's done, which one's not, because it's gonna show all of them in this little window right here. So I click connect, and it says failed to open. Now, there are gonna be two things that are going on here. One, it's a driver problem, which is entirely possible. Or two, I have something else open that it's getting mad about. In this case, its Visual Studio is grabbing onto that board. Most people aren't going to deal with that though. I was building a custom firmware for the Matrix. Now let's try this again. Same deal, failed to open. Okay, now I know it's a driver problem. Really, the only reason that I'm showing this is so that you all know that it's a really simple solution and you don't have to Google around. I'm going to have the link to where to download this program. Okay, so I'm going to go uninstall and then install it again. And it's successful. But will it work? Just going to do a quick refresh. And this install, there's of course going to be a link in the document. Why are you mad at me? Okay. Let me just make sure I don't have anything left open that could be interfering with that, because there's some weird programs that it would get really mad about. My 3D printer slicer, Cura, it got mad about that. I have no idea why. Okay, with any luck, this time it'll work. But this is kind of what DIY is all about. Okay. So that one's going to be a butthead, which does happen. It's entirely possible that I managed to fry it or something like that. That type of stuff happens. It just is what it is. There are $3 or less boards. So I'm going to try one of my other boards, see how it works. And connect. And you absolutely suck. Okay. Sorry for flipping through the scenes. I'm just trying to figure out what's going on. Technical issues, please stand by. But if I can't get this working within the next couple seconds here, I will just write a step-by-step into the document and we'll call it good from there. Ha, okay, we're in business. Now, this one I just called class test, but I'm gonna say, we're gonna erase it. Because I want you to see how easy this is to do. Okay, now this is what you would see if you were just plugging in a brand new board. Sorry, it takes a minute. And I should have thought of it and had a clip ready to go. Oh my goodness, it's already 3:54. So my apologies for all the fumbling around. But I did want to leave some time at the end for any questions you may have while this is kind of installing. And then I'll show you what the basic setup looks like. So anybody, feel free.
Sure. How insane am I to think about, because I do have a pack that I bought from Adafruit about putting LEDs on fabric. Am I insane to make
No,
wearable?
actually,
Really cool.
not at all. So there was a guy I was just watching on YouTube. You're talking about just straight up embedding them in fabric?
I'd like to make it so I can remove it so I can actually wash it, because I might be making a giant cloak that might light up now. Maybe.
Okay.
Maybe, or like, I would love to have like a crown that I can put on that has like cool lights. I don't know. Maybe I want to play Doom on my cloak.
So, fun thing, I actually saw somebody do that for his holiday display.
That's amazing.
All he did, he took different strips of these outdoor Christmas lights that you can buy, and I'll have a link to them. They're not expensive at all. I think it's like 50 feet for 18 bucks.
Yeah.
He just hung them on his garage and was able to play Doom. He did some wacky things with the firmware to do it, but
Yeah.
he did it. it was amazing.
I just love the idea that playing Doom is like the standard of like, I bet I could play Doom on my watch. I want to get a
Oh,
glasses that I could probably play Doom on. That'd be nice. I
right.
want a ring that I could play Doom on. I don't know how that would work. It's fine. I just want
Okay. But yeah, you can totally do that. And I'm going to show you a video right now. This is what she's a professional artist, but she's sort of one of my students in LED work.
Mhm.
Um, I kind of walked her through how to do this sort of stuff, how to use the controllers and all that. So I'll show you this. She makes puppets and animatronics. Do you see the fur on the puppet's back? How it's green?
Yeah.
She embedded LEDs down in the fur.
Oh, that's cool. So it glows. Can
Yep.
she change the colors of it? Because that's so cool.
Yes, she can. She
Oh,
is using the exact same LEDs that I've shown you here today.
super cool.
Yep. She was actually ordering them from Adafruit and spending about 10 times as much.
Yeah,
Could,
it's a nice place to visit. It's expensive.
yeah, exactly. All right, so this finally finished installing, and so right now I'm just gonna click skip because I don't want to connect it to my Wi-Fi. If you're out somewhere, you're not gonna want it on your Wi-Fi anyway. So if I click skip, it's gonna get mad at me. Okay, I guess I'm connecting it to my Wi-Fi, but you don't need to. Because all I would have to do on my phone is connect to it and set it up. It puts out its own wireless access point. And boom. This is the controller that I just set up. So for setting these up, all you have to do is click configuration, you go to LED preferences, and this is kind of what I was talking about, not blowing out your ESP module. Where it says enable automatic brightness limiter, you don't want to go over 1 amp powering it directly off of the ESP module because you will blow it out. This will limit it and it just won't be as bright. But then you just tell it, okay, I have WS2812B LEDs. That's this one right at the top because it also includes the 2815s, all of that. And there's 8 billion other kinds of LEDs. So I click that one. The company that I order from, their color codes are in GRB, not RGB. So then you set the length, you set what's called the GPIO, which is just what pin it's on. And every single one of these chips has a different pin number. So what I'll do is the ones I buy, I'll include the pin out on the documentation for it. But you tell it which pin it's on, you click save, and then it's done. That is all it takes. But you can name it. And that way, like if you have multiple instances of WLED running in your house or in your setup or in your cloak, then you can say, okay, I want to use this one. And, say it's such and such room or under cabinet lighting, what have you. But then I'm going to go to Wi-Fi setup and show you. Here's the access point. If it's not connected to Wi-Fi, it'll automatically broadcast. So if your internet goes down or anything like that, you can still deal with it. But that is it for the basic setup of WLED. I will include videos of more animations and stuff in the documentation. But that's pretty much it for my presentation. Do we have any other questions?
And I,
I can show you 800 videos on what this can do. I just don't want those to be recorded because I don't own them. But sorry, Kelly, go ahead.
I was just say I can stop recording, so it won't be later. So I'll stop right now.